Good morning, everyone. Today, let's have first an activity entitled Find Some Words. Anyone wants to read our procedures?
The class will be divided into 5 groups. Each group will be given a crossword puzzle printed on the bond paper. Each group will find the words or phrases and circle it. Criteria: correct answer 50%, cleanliness 20%, presentation 20%, and group participation 10%. The group will get the highest percentage will be declared as a winner, and a chance to win 100 pesos using a raffle draw.
Now, here are the answers in our activity. Certain, impossible, chance, unlikely, likely, probability, event, outcomes, toss a coin, draw a card, roll a die. And the winner. Congratulations to group number 2. Remember that the words will help us to understand our lesson later.
Before we proceed to our new lesson, we will have an activity that will help us in understanding our topic for today.
I will ask you some question and you will answer me based on what you observe. Is that clear? Now, here are the procedures. Number 1. The question will be flashed on the screen. You have 15 seconds to read and answer. Number 2, this is a multiple choice. You will write the exact word on your paper. Again, you will write the exact word on your paper. One correct answer is equivalent to 1 point. There are 5 questions in total. The student who will get the passing score, which is 3 points, will be given 2 additional points, and this will be added to your score in your quiz. Remember to raise your answer before the time is up. Strictly no erasure and be honest. Are you ready? Okay, here is the question number 1. Question number 1. What do you call a measure or an estimation of how likely an event is to occur? Variability, durability, probability, or responsibility? You have 15 seconds to answer. Time is up. Now let us know if variability is correct. Okay, that is not correct. Durability? Not correct also. Responsibility? That is not correct. And last, probability? That is the correct answer. Our answer is probability. Next question, question number 2. What do you describe an event with a probability of 1, it blank to happen? Certain, impossible, likely, or unlikely? You have 15 seconds to answer. Okay, time's up. Let us see if certain is correct. Very good. Our answer is certain. Again, question number 2, the answer is certain. Next question. Question number 3. Which of the following does not belong to the group? Again, which of the following does not belong to the group? Likely, certain, simple, or impossible? You have 15 seconds to answer. Time is up. Let us know if likely is correct. That is not correct. How about certain? That is not also correct. Impossible. That is not correct. Our correct answer is simple. Again, the correct answer is simple. Question number 4. The local weather forecast said that there is a 70% chance of rain tomorrow. What is the probability that it will not rain tomorrow? 0.7, 30, 70, or 0.3? Again, 0.7, 30, 70, or 0.3. Your timer starts now. Time is up. Our answer for this question, let us know it is 0.7 is correct. That's not the answer. How about 30? That is not also the answer. How about 70? That is not the answer. The correct answer is 0.3. Again, the correct answer is 0.3. Next question. What is the probability of getting 4 and rolling a die? Again, what is the probability of getting 4 and rolling a die? 5/6, 1/6, 0/6 or 0, 6/6 or 1. Your timer starts now. Time's up. The correct answer is 5/6 is not 1/6.
Let us watch a short video presentation, and those who are absent and can't attend our class due to the different reason will be given a copy of this plus the module that I gave to you.
These are the guide questions, and I also include this in your module.
Hi, I'm Rob. Welcome to Math Antics. In this video, we're going to learn about how to do math with things that only sometimes happen. They might be likely or unlikely. We're going to learn about probability. Usually in math, we deal with things that always happen the same way. They're completely certain. Like if you add 1 and 1, you're always going to get 2. If you multiply 2 and 3, you're always going to get 6. There's no uncertainty at all. But in the real world, things aren't always so predictable. Take a coin toss, for example. We can't predict whether it'll be heads or tails. It's unpredictable or random. And that's why some people will flip a coin to help decide which of two things to do. That's how I make every decision in life. Why am I not surprised? Oh no. Good luck. But even though we don't know what each coin flip is going to be, we do know a few things about it. We know that with a fair coin toss, that heads is just as likely to show up as tails. The probability of an event, like getting heads or getting tails, is a value that tells us how likely that event is to happen. With our coin toss, since each side is just as likely, and there's only 2 sides to a coin, if we flipped a coin a lot of times, we should expect that about half the flips will be heads and about half the flips will be tails. That means that the probability of flipping heads is the fraction 1/2, and the probability of flipping tails is also 1/2. Let's look at this in a little more detail on something called a probability line. It's a number line that goes from 0 to 1. A probability of 0 means that an event cannot happen. It's impossible. And a probability of 1 means that an event is definitely going to happen. It's certain. That's why the probability line only goes from 0 to 1. An event can't be less likely than impossible, and it can't be more likely than certain. A probability of 1/2, like with our coin toss, means that an event is just as likely to happen as it is to not happen. A probability less than 1/2 means that an event is unlikely, and a probability greater than 1/2 means that an event is likely. Oh, and in addition to fractions, it's also common to write probabilities as decimals or percentages, since you can easily convert between those three. A probability of 0 is the same as a 0% chance of something happening. A probability of 1/2 is the same as a 50% chance of something happening. And a probability of 1 is the same as a 100% chance of something happening. Now that you know how a coin toss works, let's see an example of an event that is unlikely, using something a little more complicated than a coin. Let's take a look at dice. A standard die has 6 sides numbered 1 through 6. When you roll it, any of those sides is just as likely to come up as the others. That sounds a lot like flipping a coin, doesn't it? each side of a die is just as likely to come up as the others, and each side of a coin was just as likely to come up as the other. So you might expect that the probability of rolling a 3 is 50%. But remember, with a coin toss, there are only 2 possibilities, heads or tails. With dice, there are 6 possibilities, and that's going to make a difference in its probability. One way to think about it is that it's certain that one of those 6 sides will land facing upwards, which is a probability of 1 or 100%. But since only one side can face upwards for a given roll, we have to divide up that value among all the possibilities. In the case of a coin toss, since there were only 2 possibilities, we had to divide the probability by 2. 1 divided by 2 is 1/2, which is the decimal 0.5 or 50%. But with the die, we need to divide the probability up evenly between 6 possibilities. 1 divided by 6 is 1/6, which is equivalent to 0.167 or 16.7%. So that would be right here on our probability line. That means it isn't likely that I would roll a 3, for instance, but it's just as likely as rolling any other number. And since all 6 numbers have the same probability, each number should come up about as often as the others. To see if they do, I'm going to conduct some trials. Remember, the probability of flipping heads is 1/2, and the probability of flipping tails is 1/2. The probability of rolling a 1 is 1/6, and the probability of rolling any other number on the die is 1/6. If you add up the probabilities for the coin flip, you get 2 over 2, or 1. And if you add up the probabilities for rolling a die, you get 6 over 6, which is also 1. And that's not just a coincidence. If you add up the probabilities of all possible outcomes of a trial, the total is going to be 1, or 100%, because it is certain that at least one of those possibilities will happen. Let's look at some more examples. For these examples, we'll use a spinner. If we had a spinner with just 6 equally sized sectors, the probabilities would be exactly the same as with dice. So we want a few more sectors. There, that's more like it. Now we have 16 equally sized sectors. So what's the probability of spinning a 12? Well, just like with dice, where we had to split up the 100% between all 6 possibilities, we'll do the same thing now, but we'll split it up between 16 possibilities. So the probability of spinning a 12 is 1 over 16, or about 6%, which is right here on the probability line. We can see that the probability of spinning a 12 is less likely than the probability of rolling a 3. And that makes sense because there are more possible outcomes with our spinner. But what if we color some of the sectors a different color, and we want to know the probability of spinning a certain color? Now we have 5 sectors colored blue and 11 sectors colored yellow. So what's the probability of spinning a blue? Remember how with the coin toss, we ended up with the fraction 1 over 2, and with the die roll, we got the fraction 1 over 6? In both cases, we had 1 as the numerator, and that's because we were interested in only one of the possible outcomes, like the probability of flipping heads, or the probability of the number 3 being rolled. But in this case, the top number of our fraction will be 5, because any of these 5 sectors will give us the color we want. And the bottom number will still be the total number of possibilities, which is 16, because that's how many total sectors we have. So the probability of spinning a blue is 5 over 16, or about 31%. That's still considered unlikely, but it's more likely than spinning a specific number. And this method will work for figuring out the probability of any event. You just make a fraction with the numerator as the number of outcomes that satisfy your requirement, and the denominator as the total number of possible outcomes. Let's try the same method to find the probability of spinning a yellow. Our top number should be 11 because there's 11 yellow sectors, and our bottom number should still be 16. So the probability of spinning a yellow is 11 over 16, or about 69%. Now we finally have a probability that's considered likely. And it makes sense because you can see by looking at our spinner that it's more likely to spin a yellow than a blue. And you'll notice, if we add up 5 over 16 and 11 over 16, we get 16 over 16, or a probability of 1. So that's a good sign that we did it right. Let's look at another example. Suppose we have a bag of marbles. There are 3 green marbles, 7 yellow marbles, and 1 white marble. If we mix them all up and pull out a marble at random, what's the probability of it being green? Well, the top number of our probability fraction will be 3 because there's 3 green marbles. So there's 3 outcomes that get us what we want. And the bottom number will be 11 because there's a total of 11 possible marbles that we could pull out. So the probability of pulling out a green marble is 3 over 11, or 0.27, or 27%. It's It's right here on the probability line. That means it's unlikely. And that makes sense because you can see that it would be less likely to pull out a green marble than one of the other ones. Let's try this again for calculating the probability of pulling out a yellow marble. This time, the numerator of our fraction will be 7 because there's 7 yellow marbles. The denominator will still be 11 because there's still 11 marbles total. So the probability of pulling out a yellow marble is 7 over 11, or 0.64, or 64%. Another example of an event that's likely. How about pulling out the white marble? Well, the top number will be 1, since there's only one white marble, and the bottom number is still 11. So the probability of pulling out a white marble is 1 over 11, or 0.09, or 9%. Not very likely. And if we add up these probabilities, we get 11 over 11, or 100%, just as we expected. Alright, so you should have a pretty good handle on basic probability now. You just have to remember to make a fraction with the numerator being the number of outcomes that give you what you want, and the denominator being the total number of possibilities. And we learned about the probability line, and that a probability can't be less than 0 or greater than 1, or 100%. We also learned that the more trials or experiments you conduct, the closer your results will get to the expected probabilities. Of course, the way to get good at it is to practice, so be sure to do a lot of problems on your own. As always, thanks for watching Mathantics, and I'll see you next time.
Now let us answer the guide questions. Number 1, what is probability? Number 2, what is probability scale? And number 3, how to find the probability of an event. Number 1, what is probability? Probability, according to our module and the video that I presented, probability is a measure of how likely an event is to occur. Next, what is probability scale? A probability scale is a scale where we can find if the event will unlikely or likely to happen. So the range from 0, or if the probability of an event is 0, it is impossible to happen. Again, if the probability of an event is 0, it is impossible to happen. Or greater than 0 to less than 50% or 0.5, the probability scale or the event is unlikely to happen. If it is greater than 50% to less than 100% or 1, the event is likely to happen. And if it is exactly 1, or the probability of an event is 1 or 100%, the event is certain to happen. So that is probability scale. That was on your module, and it is also presented in our video a while ago. Okay, the number 3 question is how to find the probability of simple event. We have the formula. The probability of an event is equal to the number of favorable outcomes divided by number of all possible outcomes. So example, if we are going to toss a coin, we have the tail and the head. So there is one tail and one head. So if I toss the coin, if the question is what is the probability of getting a tail if we toss a coin? So the number of favorable outcomes, there is only one tail, so the numerator is 1, and the number of all possible outcomes, so there are tail and head in one coin. So therefore, if we toss a coin, the probability of an event is 1 over 2. So therefore, we have 1/2 or 50% or 0.5. Okay, so now for us to understand our lesson clearly, we have here 4 examples. Number 1, the weather forecast shows 70% rain. The probability that it will rain is equal to 70%. So here we are going to determine if the event is impossible to happen, unlikely to happen, likely to happen, or certain to happen. Okay, again, we are going to determine if the given event is impossible to happen, unlikely to happen, likely to happen, or certain to happen. So the number one question is, the weather forecast shows 70% of rain or 70% chance of rain. So the probability of an event that it will rain is equal to 70%. So at the right corner of, or right top corner of our screen, you can see the probability line. So we are going to determine if where is the 70% or 0.7 in our probability line. So as you can see, we have 0.5 to 1. So 0.5, 0.7 or 70% is greater than 0.5, and that is less than 1 or 100%. So therefore, the correct answer in our example number 1 is likely. So let us see if it is correct. Yes, that is correct. Likely is the correct answer in our example number 1. How about number 2? The probability of getting an 8 in rolling a die is 0. So the probability of an event or 8 is equal to 0. So therefore, if it is 0, as you can see in the right top corner, there is a probability line. The 0 will fall under the impossible. So it is impossible to happen. Why? Because there is only 1, 2, 3, 4, 5, 6 numbers on a die. Okay? So let us see if it is correct. Yes, impossible is the correct answer. That is example number 2. How about example number 3? The probability of getting a face card in a deck of cards is 0.23 or 23% or 3 over 13. We have here the face card is equal to 0.23, 23% or 3 over 13. The event will fall under, if it is 0.23 is less than 0.5 but it is greater than 0.0, so therefore the event falls under unlikely. Therefore the correct answer is unlikely. Okay, so that is question number 3. How about question number 4? The probability of getting a number less than 7 in tossing a die is 1 or 100%. So our probability or less than 7, that's not 5, is 1 or 100%. If it is 100%, it will falls under the certain. So 1, 1.0 or 100%, that is certain. Ibig sabihin, it is certain to happen. Mangyayari at mangyayari siya. The probability of getting a number less than 7 is 1, and that is certain. Let us see if it is correct. Okay, so that is correct. So our answer is correct, and that is the way on how to determine if the event is impossible to happen, unlikely to happen, likely to happen, or certain to happen. Or sometimes it is as likely as not, or it is in the middle. So if it is 0.5, just like tossing a coin, that is 0.5, that is as likely as not. Okay, 1/2. If the probability of an event is 1/2 or 0.5 or 50%. Now, let us use our formula in getting the probability of an event. Number 1, what is the probability of getting ahead in tossing a coin? We have the formula, probability of event is equal to the number of favorable outcomes divided by the number of all possible outcomes. Since the possible outcomes are head and tail, the number of favorable outcomes that we have is 1, since our head is only 1. And the number of all possible outcomes, we have the possible outcomes are head and tail, so our denominator is equal to 2. Therefore, our answer is 1/2 or 0.5 or 50%. Next, number 2. Find the probability of getting 4 in rolling a die. We have our formula. Now let us know about the possible outcomes. So we have 6 possible outcomes. We have 1, 2, 3, 4, 5, and 6. And the number of favorable outcomes, since we have only 1, 4, therefore our numerator is 1, and that is the favorable outcome. Then the number of all possible outcomes, as I said earlier, we have 6. So therefore, our answer is equal to 1 over 6 or 0.17 or 17%. And for your seat work, I will give you a copy and then you have 5 minutes to answer your seat work. After that, you may pass your work. Okay, your timer starts now. How will you apply our lesson in a daily life situation? Probability can help us to determine or predict the chance of doing something or the chance of what will happen. That's why it can give us a clue on what will be the solution if there is a higher chance of having a problem in a specific event. And for your quiz, you have 10 minutes to answer the questions. And if you're done, please review your answer, and then if you are sure, please pass it. Okay, so your time starts now. Please answer your assignment and then pass it tomorrow. Thanks for listening. Goodbye.